On to the next video. Just so you know, all these videos are together. Line 22 starts at A, goes all the way up to E11 as of June the 24th. This one's 22E3. So if you're looking at these videos, you want to start with A, okay? So part 242, line 22, E3, chlorocarbon, H2 hydrogen atoms, pi bond, electrons, fusion formula, UFO 5G Wow Seti. With the UFO 5G, it means there's a formula for the fuel, okay? This is the Wow Seti alien radio signal. June the 11th, 2012 is when I started working on this one, and today's June 24th. My thoughts. The key word is fusion here. I keep hearing that word. So there's the graph that came up with the last one. The two representations of organochloride, chlorocarbon, and organ chloride, chlorine, chlorocarbon, chlorinated hydrocarbon, or chlorinated solvent. I dare you to say that really fast. Chlorinated solvent is an organic compound containing at least one covalently bonded chlorine atom. Their wide structural variety and divergent chemical properties lead to a broad range of applications. And here's our little graphs here and here. Okay, so a covalent bond forming H2 right, where two hydrogen bonds share the two electrons. A covalent bond is a form of chemical bonding that is characterized by the sharing of pairs of electrons between atoms. The stable balance of attractive and repulsive forces between atoms when they share electrons is known as covalent bonding. Covalent bonding includes many kinds of interaction, including O bonding, pi bonding, metal-to-metal bonding, agnostic interactions, and three center two-electron bonds. So here's another little graph for you. This says two p orbitals forming a pi bond. And some more stuff here. Electron, atomic, and molecular orbitals showing a pi bond at the bottom right of the picture. Okay. There's that. There's all these little markings there. Okay, so pi bonds. In chemistry, pi bonds are covalent chemical bonds where two lobes of one involved atomic orbital overlap, two lobes of the other involved atomic orbital. These orbitals share a nodal plane which passes through both of the involved nuclei. The Greek letter pi in their name refers to p orbitals. Since the orbital symmetry of the pi bond is the same as that of the p orbital, when seen down the bond axis, p orbitals usually engage in this sort of bonding. D orbitals also engage in pi bonding and form part of the basis for metal-to-metal multiple bonding. Pi bonds are usually weaker than sigma bonds. From the perspective of quantum mechanics, this bond's weakness is explained by significantly less overlap between the component p orbitals due to their parallel orientation. Pi bonds result from overlap of atomic orbitals that are in contact through two areas of overlap. Pi bonds are more diffuse bonds than the sigma bonds. Electrons in pi bonds are sometimes referred to as pi electrons. Molecular fragments joined by a pi bond cannot rotate about that bond without breaking the pi bond, because rotation involves destroying the parallel orientation of the constituent p orbitals. So anything to do with rotation or electrons, that's very interesting, because the UFO design does have a rotating body going around a portion that kind of floats midair. So obviously this is going to have something to do with more than just the fuel. For homonuclear diatomic molecules, bonding pi molecular orbitals have no nodal planes that pass between the bonded atoms. The corresponding antibonding or pi star molecular orbital is defined by the presence of an additional nodal plane between these two bonded atoms. So we're going to Google diatomic molecule, and up comes this graph, which you probably can't see because I can't read it. It looks like it's numbers, and then it's got the group 1 is M, 2 is ME, 3 is LI, 4 is something, 5 is something, C, 5 is B, 6 is C, 7 is N, 8 is O. Okay? A periodic table showing the elements that exist as homonuclear diatomic molecules under typical laboratory conditions. A mnemonic to remember them is that there are 7 and they form, excluding hydrogen, in the shape of a 7 on the periodic table. Diatomic molecules. Diatomic molecules are molecules composed of only 2 atoms of either the same or different chemical elements. The prefix di is of Greek origin, meaning 2. Common diatomic molecules are hydrogen H2, nitrogen N2, oxygen O2, and carbon monoxide CO. 7 elements exist as homonuclear diatomic molecules at room temperature as H2, N2, O2, F2, Ci2 or Cl2, Br2, and I or L2. I'm not sure. It doesn't tell me if it's an I or an L. Many elements and chemical compounds aside from these form diatomic molecules when evaporated. The noble gases do not form diatomic molecules. This can be explained using molecular orbital theory. See molecular orbital diagram. Vibrational energies. Another way a diatomic molecule can move is to have each atom oscillate or vibrate along a line, the bond connecting the 2 atoms. The vibrational energy is approximately that of a quantum harmonic oscillator. EVIB equals N plus, well, there it is there. Okay? Where N is an integer, H is the reduced Planck constant, and W is the angular frequency of the vibration. Comparison between rotational and vibrational energy spacings. So the spacing and the energy of a typical spectroscopic transition between vibrational energy levels is about 100 times greater than that of a typical transition between rational energy levels. Rotational energy. The rotational energy or angular kinetic energy is the kinetic energy due to the rotation of an object and is part of its total kinetic energy. Looking at rotational energy separately around an object's axis of rotation, one gets the following dependence on the object's moment of inertia. So there's the quotient there, and where W is the angular velocity, I is the moment of inertia around the axis of the rotation. Again, we have rotation coming up again and velocity. Both these things would have something to do with this UFO idea. E is the kinetic energy. The mechanical work required for applied during rotation is the torque times the rotation angle. The instantaneous power of an angularly accelerating body is the torque times the angular velocity. For free-floating, unattached objects, the axis of rotation is commonly around its center of mass. Note the close relationship between the result for rotational energy and the energy held by linear or translational motion. And that would be that. In the rotating system, the moment of inertia, I, takes the role of the mass, m, and the angular velocity, w, takes the role of the linear velocity, v. The rotational energy of a rolling cylinder varies from 1/2 of the translational energy if it is massive to the same as the translational energy if it is hollow. As an example, let us calculate the rotational kinetic energy of the Earth. As the Earth has a period of about 23.93 hours, it has an angular velocity of 7.29 times 10 to the 5 radius. The Earth has a moment of inertia, I equals 8.04 times 10 to the 37 kg.m2. Therefore, it has a rotational kinetic energy of 2.138 times 10^29 J. Part of it can be tapped using tidal power. This creates additional friction of the 2 global tidal waves, infinitesimally slowing down Earth's angular velocity W. Due to conservation of angular momentum, this process transfers angular momentum to the moon's... this process transfers angular momentum to the moon's orbital motion, increasing its distance from Earth and its orbital period. See tidal locking for a more detailed explanation of this process. I haven't looked at that. Interesting. So this is 11th of June 2012. Keywords that stand out: H2 plus 2 hydrogen atoms. June 11, 2001 again. Earlier, it was hydrogen atoms. Has come up several times in line 22. A to E, it's important. It's going with the word fusion that comes to mind. Actually, line 22 now goes from A to E, well, A to E up to E11. Okay. Still trying to figure out what the message here is. Formula ID is based on the keywords in the data. H2 plus 2 hydrogen atoms plus chemical bonding plus shared pairs of electrons between atoms plus the balance plus attractive plus repulsive plus forces plus between atoms plus share electrons plus covalent bonding plus interaction plus pi bonding electrons plus neutrinos plus 3 center 2 electron bonds plus diatomic molecules plus 2 atoms plus different chemical elements plus homonuclear plus hydrogen plus nitrogen plus oxygen plus carbon monoxide plus 7 elements exist as homonuclear diatomic molecules at room temperatures H2, N2, O2, F2, Ci2, Br2, and I2 plus noble gases. June the 11th, 2012, my thoughts. All these keywords came up in the previous line 22 data in this formula. There's some sort of connection here. June 11th, 2012. Formula ideas from keywords in that data. Diatomic molecule plus atom plus oscillate plus vibrate plus bone plus connect plus 2 atoms plus vibrational energy plus quantum harmonic oscillator plus integer plus reduced Planck constant plus angular frequency plus vibration plus rotational plus energy plus spacings plus spectroscopic transition plus rotational energy plus kinetic energy plus axis of rotation plus moment of inertia plus angular velocity plus the moment of inertia plus kinetic energy plus torque plus power plus accelerating body plus torque angular velocity plus center of mass plus linear velocity plus rotational energy plus rolling cylinder plus translational energy plus earth plus tidal power plus friction. That's supposed to be friction. I don't know how to spell. Plus 2 global tidal waves plus slowing down plus angular velocity plus conservation plus angular momentum plus transfer plus orbital motion plus increasing plus distance plus tidal locking. Okay, so that's it for that video. We're going to go on to line 24E4 next.